If you are trying to build a data science portfolio, this is for you. So the commenter had learned a new machine learning technique, SVD, in math class and was looking for project ideas. Now, one of the biggest mistakes that data scientists can make sometimes is they have a solution and they go in search of a problem. Now, what this looks like on the job is you might have data scientists who build some really fancy model, but the stakeholders don't actually want it or need it. And that can cause a lot of tension because the data science team put all this time into building a model, but then it doesn't get used. Meanwhile, the stakeholders are frustrated because there may be simpler things that they asked for that don't get done because the data science team was busy making this fancy model. So rather than just thinking, where can I use SVD? I really recommend you start thinking about what kind of problems you want to solve or that you can solve. And then from there, you can use all these, like a wide variety of models, and compare the results, which is a great strategy and something you would definitely want to do in a data science team, which is model selection and model validation. And I'm going to get to the SVD stuff in a second, but I want to add one more thing. A lot of times, really good project ideas use public policy because there is a lot of publicly available data that's out there, but a lot less publicly available data from, say, like private companies. Now, if you are specifically interested in SVD and you just want to get some practice, so I did a quick search on it, and one of the questions that I saw come up, because one of its methods, one of its uses is dimensionality reduction, is people ask SVD versus PCA. So you could go out there, you could find some data, you could generate some data, and you could use different techniques of dimensionality reduction. You could use PCA, you could use SVD, and see which one performs better. And one of the benefits of simulating or generating your own data is that you might be able to find different cases in which SVD does better than PCA, or some cases where PCA does better than SVD, and that would actually be a really interesting result. Again, take all this with a grain of salt. I am not a machine learning engineer, and I literally just spent a few minutes Googling what SVD is. But the big picture is companies care about you solving business problems, and they don't care how you did it, but they just want to know, can you solve this problem? And it's great if you have a variety of techniques that you can use and say, I tried technique 1, 2, 3, and 4, and then I selected technique 3 because it performed the best based on these evaluation metrics. That's what you really want to do.